Factoring of trinomials. I discussed this extensively. This is our third technique of factorization. We've already discussed when the leading coefficient is 1. I've already discussed when the leading coefficient is -1. So now let's shed some light on how we solve a question when the leading coefficient is greater than 1. And when we have a trinomial that is a perfect square, how do we actually solve that? Right? So let's do this. So if you want, right? If you want, you can rewrite all of this down. You have your notes on that, so write all of your notes there. Then come to number 2, write all of your notes that I've just given you now. Then come to number 3, structure it out exactly as I have it here. Write down your case 1 and all of the notes that I gave you for case 1. Now write down case 2 and all of the notes that I will give you. And then case 3 we've already discussed at grade 9, so write all of your notes there. And then we'll move on. Even if you photocopy it and you stick the notes at the top, that's good enough. But I just want you so you have a complete list of everything that could be tested, and you have it at one location, so you don't have to scramble around looking for your information from different books and so on, right? We can adopt the following approach for case 1 above. So this, in case 2, I'm teaching you a different technique that we utilize when the coefficient, so when the leading coefficient is greater than 1. So if you're given 2x squared plus 3x plus 1. So the leading coefficient is not 1 or it's not -1. Because if it was -1, I could have extracted the -1, and in brackets I would have had a leading coefficient of 1, and then I would apply case 1 that we've done already. But now I'm saying, what if it's 2? What if it's 3? What if it's -3? What if it's -4? How do we solve a question like that? Right? So there's a new technique that I will teach you, and this technique that I will teach you will apply for every factorization question. So that is why I said the following approach will apply for case 1 above. It's a bit more complicated approach. That's the reason why we don't use it for case 1, right? When the leading coefficient is 1. We only use it when the leading coefficient is other than 1. So it could be greater than 1 or less than 1 on the negative side. However, as I said, yeah, it is more useful to utilize when the leading coefficient of the trinomial is other than 1, exactly as I've explained just now. Here, we multiply the leading coefficient to the last term, which is the constant of the trinomial, and then find factors of this number whose sum or difference will yield the middle term. Right? So, let's do that. If we zoom in here, we can see that we have to multiply the leading coefficient by the last term, which is a constant, right? Be very careful. Make sure that you write your trinomials in this form so that everything that I'm saying will make sense and will work. So it'll be 2 times 12 gives us what? 24. List out the factors of 24. So it'll be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now this is the very, very important part, because the product must give you the 24, but the sum of these terms must give you what? The middle term. So remember, this is not just 24, it's plus 24. So remember the rules that we said, that when you multiply these two numbers together, it must give you what? The last term. But when you add it together, it must give you the middle term. So since this number is positive, right? Since this number is positive, that means both the factors must either be a plus plus or a minus minus. But since the middle term is positive, it has to be a plus plus. So from all of these factors, which two numbers when added together will give you 10? 6 and 4. Very, very important. So let me restate that. Our first rule when utilizing this technique, when the trinomial has a leading coefficient that is other than 1, is multiplying the leading coefficient by the constant. Gives you 24. But it doesn't only give you 24, it gives you plus 24. So you have to look for two numbers, and when multiplied together will give you the 24, but when added together will give you the middle term. And since this term here, or since this product is positive, that means the factors that's going to re-express that number must either be a plus plus or a minus minus. But since the middle term is a plus, it has to be a plus plus. So therefore, if I have to let's put some clarity to this, it'll be 2x squared plus 4x plus 6x plus 12. Right? So what I just said now, that when these two terms multiply together, the 4 and the 6 will give you the positive 24, but when added together will give you that middle term. So this is why it's very important that we follow our rules. If there was a negative here, then one term has to be positive, one term has to be negative, and we follow all of the rules that we use from case 1. Now here, Find the HCF between the two terms. So between here and here, I'll have 2x into x plus 2, because 2x times x will give you 2x squared, 2x times 2 will give you 4x, plus 6 into x plus 2. And x plus 2 is our common binomial factor, so therefore we have 2x plus 6 and x plus 2. Now, something that's very fascinating about this is when you utilize this technique, and you'll know that you did it right. If you take any two terms and you pair them, you will get to the same answer. So remember when we did fraction by grouping, I said that you have to be very intentional with which two terms you choose. When you're doing this technique here, for case 2, you can choose any two terms. So let's choose that term and that term. Between the first and the third term, I can see that it's 2x into x plus 3 plus 4 into x plus 3. So therefore we have 2x plus 4 and x plus 3. If I have to distribute this to check if we're correct, it'll be 2x squared plus 6x plus 4x plus 12. So this is something that's very fascinating about this technique. Even if you have to open this out, you'll be able to get that same expression at the top, just to ensure that we are correct. Alright, so that's something very fascinating. So let's do another example so I'll really drive this point home, right? Okay, so let's say we were given this question here, something a bit more complicated, but very simple, very simple idea. Then what you would do is, you would multiply the leading coefficient. So the first thing you would say, okay, I have a trinomial, right? It has the highest degree of 2. Perfect. So now we check the list. Then I see that we have a leading coefficient that is other than 1. Right? So it's not 1 or minus 1. It is something other than 1. It's in fact minus 2. So therefore I have to apply the technique that I learned under case 2. What do? I multiply the leading coefficient by the constant term. Minus 2 times 12 is what? Minus 24. Very simple. Find factors of 24, and I'll be 1 times 24, 2 times 12, 3 times 8, 3 times 8, and 4 times 6. Don't worry about the minus for now, right? We'll get back to that. Then what we would do is, we would say, we have to be very intentional about what we choose, because we have to find terms that when multiplied together must give you this, the product, that must give you this, but when added together must give you the middle term. So let's do that. So we know that it must be a plus minus. The factors that we choose to re-represent the middle term must be a plus minus. And since the middle term is positive, the bigger number will take the plus. Remember, I've done this extensively at grade 9. If you paid attention to what I said at grade 9, I said, hey, this middle term is very small. So therefore, I won't choose the factors that are at the top. I'll choose factors that are more at the bottom. So let's say we put the plus and the minus here. Plus 8 minus 3 is what? 5. Plus 6 minus 4 is what? 2. So therefore, I'll have minus 2x squared plus 6x minus 4x plus 12. And then now, if you look at these two terms here, the HCF between these two terms will be minus 2x into x minus 3. Minus times minus is a plus. 2 times 3 is 6. X times 1 is x. Minus 4 into x. Minus times of what will give you a plus? Minus 4 times what will give you 12? 3. Right? SNV. Follow SNV all the time. So therefore we have minus 2x minus 4 into x minus 3. And if I have to distribute this, it will be minus times a minus is a minus. 2 times 1 is 2. X times x is x squared. Minus times a minus is a plus. 2 times 3 is 6. X times 1 is x. Minus times a plus is a minus. 4 times 1 is 4. 1 times x is x. SNV, remember I'm following SNV. Minus times a minus is a plus. 4 times 3 is 12. And we in fact have what we had at the top here. And if you have to simplify it, you'll get the initial question. Very simple idea. It's just a different technique that we utilize to solve trinomials with the highest degree of 2, but the leading coefficient is other than 1. Now, let's say that the leading coefficient was minus 1, right? Then you would utilize this technique here as well. You could say minus times that number and then just follow all of the steps that I've just discussed. Now, it's very important to ask ourselves this question, right? How is it that we got two different answers here when choosing any of the other two terms? And the answer is very simple. You see, this question, I strategically chose this question because the first rule of factorization is that we're supposed to factor out an HCF, right? And if you don't do that, towards the end, you'll have a factor that can be factorable. So if you look at this factor here, it can further be factorized into 2 into x plus 3 multiplied by x plus 2. And now this is the fully factorized form. You do the same here, you'll have, I'll do it here, you'll have 2 into x plus 2 into x plus 3. So you can see that whichever two terms you choose whenever using factoring by grouping does not matter. It will both yield the same answer, but if you forget to take out the HCF first, you have to do an additional step towards the end, right? So sometimes you may not even see it, but it is important that you first take out the HCF, because towards the end you may think, this factorization or this factorized form is factorized fully. You won't see that there's a HCF of 2 in there and a HCF of 2 in there. Right, so that's something that you must keep in mind. You can choose any two terms, but you must ensure that you take out the HCF first. That's your first rule. Right, so I wrote this here on the computer. So if you want something that's more neater, the other rules here, just pause the video and copy it down. Right? Okay. Here for case 3, I've discussed this extensively. I'm not going to go into detail. But here I said if you want to utilize case 1 to solve case 3, so hear me out. If you want to use the rules that we discussed in case 1 to solve trinomials that have a leading coefficient of -1, then you just factor out the -1. But you can utilize the rules of case 2 to solve this question by saying -1 times 6 will give you -6 and follow the rules. So let's just do that quickly, right? It'll be -1 times 6 gives you -6. The factors of 6 is 1 times 6, 2 times 3. Right? Then we know, because we have a -6 here, one factor has to be a plus, one factor has to be a minus. The middle term is positive, so therefore the bigger number will take the plus. So what we can say is x squared plus 6 minus 1 is what? Plus 5x. So therefore it'll be plus 6x minus x plus 6. Okay, so let's factorize this. We'll have minus x into x, and here will be minus times of what will give you a plus, minus 6. So it'll be minus x squared plus 6x, right? Between these two terms, you'll think that there's no HCF, but there is a HCF. It's -1. So it'll be -1 into x. So minus times of plus will give you a minus. Minus times of what will give you a plus, -6. Right? So therefore, you have minus x minus 1 into x minus 6. Now you would think, hey, this question and this are not the same, but it is. Because if you take out a minus sign here, it'll be minus into, minus times of what will give you a minus, plus. Minus times of what will give you a minus, a plus. See, minus times a plus will give you minus x, minus times a plus will give you a minus, and 1 times 1 will give you 1. So therefore you have minus x. I didn't change the question, I re-expressed it into x minus 6, and let's see what they did here. They took this into the bracket here. So they said, okay, minus into x minus 6 into x plus 1. Right, so then remember the change of sign rule. If I take this inside, I must swap the inner term. So therefore it'll be 6 minus x into x plus 1. And that's how we get the same answer here and here. Right, different techniques. You can see that this is a longer approach. That's why I would advise that you take out the minus sign, work with this trinomial question as if you have a leading coefficient of 1, then distribute the negative. Now remember, this negative can distribute into this bracket or it can distribute into that bracket, but not both, one of it, right? And that's basically how we do trinomials and the 3 different cases. Leading coefficient is 1, leading coefficient is other than 1, leading coefficient is -1. Remember, these two cases I could link these two cases, but with case 3, you could solve it using case 1 technique or case 2 technique, right? To give you a good overview, this is everything that we've discussed and every question that we discussed, and you'll be able to solve any trinomial question if you've mastered these techniques, right? Case 4, for factorization of trinomials. You see, sometimes you will be given a question like this here, x squared minus 6x plus 9. Then to solve this question, you would say, okay, I have a trinomial, there's 3 terms. It has the highest degree of 2 because I can see the x squared and I can't see x cubed, x to the power 4 and so on. So therefore that's the second thing ticked. And then I see a leading coefficient of 1. So therefore I have to employ case 1 techniques. To utilize case 1 techniques, I have to say, okay, let's find the factors of 9. Factors of 9 will be 1 times 9, 3 times 3. Then I see that this last term is positive, so therefore the terms that we'll write in the bracket has to be a plus plus or a minus minus. But since the middle term is a negative, it has to be a minus minus. It'll be minus 3, right? But then what we have here is x minus 3 all squared. So remember when we did products. When we did products, I said when you're given two identical binomials, right? You square the first term, x squared. You multiply the first term by the second term by 2. So it'll be 2xy. And copy the sign from the bracket. And then you'll square the last term, plus y squared. It's the exact same idea. You were given this, you did this. Now you're given this, you can do this. Right? But if I have to re-express this, it'll be x minus y all squared. So all you're going to do to go from year to year quickly is you square root the first term, you square root the last term, and copy the middle sign. Because if I had x plus y multiplied by x plus y, then I'll square the first term, it becomes x squared. I'll multiply the first term by the second term by 2, becomes 2xy, and copy the sign from the bracket, which will be plus, and I'll square the last term, which will become y squared. To go from year to year, I'll square root the first term, because I said square the first term. Now I'll square root the first term, which will give you x. I'll square root the second term, which will give you y. I copy the sign of the middle term, which will be plus, and it'll be all squared. Understood? So why did I do this? Why did I create this case? And why did I create a separate case for this? Because when you are given this question here, to utilize case 1 to solve this is going to waste a lot of time. And this is why I want you to write this under your factorization of trinomials. When factorizing trinomials, always check if it is a perfect square. That's the first thing you must do, trinomial. That is the first thing you must do whenever you do factorization of trinomials. I know it's the last thing that I discussed, but it's the first thing that you must do, because you can speed up the process. And how do you check if it's a perfect square trinomial? Square root the first term, x. Square root the last term, 3. Multiply the first term by the second term by 2. Gives you what? 6x. Does it give you the middle term? Yes, it does. Ignore the sign. Forget the sign. Because the sign could be plus or minus, and you have to just change the sign in the bracket accordingly. But all you have to get is the middle term, irrespective of whether the sign is a plus or minus, and you have a perfect square trinomial. See, if I have to give you another question, I could give you x squared. I could give you x squared plus 10x plus 25. I would first check. The first thing that most of you would do, you'd say, okay, I have a leading coefficient of 1, I have 3 terms, have the highest degree of 2, and plug case 1. But I can go directly from here to the answer, x plus 5 all squared, without doing all of this technique, because I could see it's a perfect square trinomial. Because if I square root the first term, it's x. If I square root the last term, it is 5. And if I multiply all that there by 2, it gives you 10x. Does it not give you the middle term? Yes, it does. Now remember, I said ignore the sign, because you could be given x squared minus 10x plus 25, and then this would be x minus 5 all squared. How did I do that? I square root to the first term, gives you x. Square root to the last term gives you 5. Copy the sign of the middle term, and all squared. Because this is the same as multiplying two identical binomials. It'll be x minus 5, x minus 5. That's how you start working faster when you start seeing these things. So the first thing that you do whenever you're given a trinomial, right, check, always check. And your dead giveaways, you would see, and you would see that this is a perfect square and that is a perfect square. But you still have to multiply to check whether it gives you the middle term. It doesn't always have to be that way, but it's just by chance, right? Certain questions you can work faster with them and others you can't, right? But it's just a chance that you take. And remember, it's a very quick process, so it's not going to take a lot of your time. See, check your perfect square, perfect square. Now remember, if I was given something like this here, x squared minus 10x minus 25, there's a minus sign here. Although this is a perfect square, but you have a minus sign, you can't take the square root of minus 25. It is non-real. So therefore, you can't solve that question. So therefore, you have to also check now. It has to be a plus sign here and a plus sign here. Just some additional information for you. But if you're comfortable with working with case 1 for now, you can do it. Like I said, this is just to work faster, just so that you can see how everything fits. I'm starting to link it back to the products section. Right now, you'll be able to solve any trinomial question given these 1, 2, 3, 4 cases, right? But like I said, the only thing that you actually need is 1, 2, and 3. Case 4, I created this specifically just to speed up the calculation process. Okay, let's move on to the last part.